Now that we've finished synthesis question 2, you all should know how this motor functions. The question we need to answer now is how fast it's actually going when it gets into a good speed, and we're going to find that through this angular frequency. There are a few ways to find that, but in this video we're actually going to be looking at current, so we'll be using this high current sensor through Logger Pro. Now, since it's a current sensor, we will be breaking the circuit, like every ammeter, so that we can put this device in series with the motor. Once we hook that on, we can take this and plug it right into Logger Pro. Now, Logger Pro is reading a non-zero current, so let's just zero that right away. Before we take data, we have two other things to think about. The first is we need to think about our sample rate and the resolution of our data. Now, if you've read the appendix, you know that a rule of thumb is to have at least twice the frequency you expect. These can vary a little bit, but most commonly they're around 20 hertz. So at a minimum, we should go into data collection and set it to 40 samples a second. Just for the sake of data, I'm going to use 400 so that we have a really nice resolution for this data. The second thing we need to think about is, because we're measuring current, we have to think about the connections in our system. And if we remember, half of the nail on the bottom of the magnet is coated in whiteout. So we should carefully think about what that will do to the circuit and what that will do to our data as we're collecting it. Right now, let's go ahead and start the DC power supply, get it to around 3 volts, kick it on, and let's collect some data. Okay, so it started getting a little rough around the end, but we know that it was running pretty well within the first second especially. So we can look at the first second, and we see a very interesting pattern. There are a few ways we can go about this to get the frequency. We can look at the peaks and just count them up over whatever distance we do, or we can throw on a curve fit and see how well a sine affects it. And it looks to be fitting pretty well. And from this, we could get a nice value for the frequency.